I need to apologize because the last lesson I did, I was going to give you a reason of why we're talking about solids now. Why we're talking not just about two-dimensional shapes, but actual three-dimensional objects. And I didn't remember to tell you why. So I want to tell you why right now. Here's why. Because a lot of the formulas and mathematical situations that life throws our way, it's not just dealing with two-dimensional shapes. I'm looking at my classroom right now. When they decided how much carpet to purchase for this room, yeah, that was just length times width, a simple area thing. Oh, that's how much carpet we need. But what if there's a bunch of bugs in this room and I want to buy a bug bomb? You know those where you let them off and they fill the room with some kind of chemical, some gas, and poisons the bugs? Well, how do I know if I need one bug bomb or 3 bug bombs? On those containers of the bug bombs, they tell you this is how much square footage or volume, square footage, that's area, but this is how much volume that this bug bomb can fill. So volume is not a two-dimensional measurement. It's three-dimensional. How do I figure out the volume of this space? That would be length times width times, and last time we talked about the depth. In this classroom, it would be length times width of the floor times the height. So why are we talking about solids now and polyhedrons? Because these are three-dimensional objects. Sometimes you're going to have to find the surface area. Let's say that you are a famous sculptor and you are sculpting an elephant. And the person that has commissioned you to sculpt this elephant is the king of Thailand. And they want to plate it in gold. And they say, how much gold are you going to need? I'll send it your way. Well, you might be tempted to be like, oh, I need, a lot. But no, you're an honest person. You say, it should take about, well, now you have a three-dimensional figure. You've got the legs and stuff, so some cylinders are the legs, and then the body of it would kind of be like maybe a sphere, but a little elongated and whatnot. You would have to figure out the surface area of this shape. That's what we're going to get into soon here, talking about surface areas and talking about volumes. So that's what we're talking about, solids. Cool. So today, what are we doing today? Surface areas of prisms and cylinders. All right. Now, I told you you're going to see formulas for the rest of your math life, and I bet you today they're just going to throw some formulas your way. You just got to know how to work with them. So let's check this out. In the real world, you're painting a storage chest. Before you begin painting the chest, you need to find the surface area. What is the surface area of the chest? You'll find the answer. Why do you need to find the surface area? Because you need to know how much paint to buy. I just bought some paint the other day, painting some boards for a structure in our backyard, and guess what? I literally have, out in my van right now, I've got a gallon of paint that I'm taking back to Home Depot. They mixed the paint for me though. I bought 2 gallons, I only needed 1. Because guess what? I just did estimating. I didn't take the time to actually figure out the surface area that I'd be painting and covering and actually give the measurement. Because on the side of the paint can it says, this covers about 500 square feet or something like that. So I'm worried, as soon as I'm done here today, I'm going to Home Depot, I'm bringing that paint in, and I'm saying, and I got my receipt, I'm saying, hey, can I get a refund or in-store credit? I don't know if they're going to give me a refund because they mixed it. If I would have taken just a little time to figure out the surface area, then, maybe I wouldn't be out $30 or whatever it cost me for that paint, Hopefully they'll give me some in-store credit. Anyway, so 15 inches, 30 inches, 15 inches. Let's see what they're talking about here with nets first. One way to represent a solid is to use a net. A net is a two-dimensional pattern that forms a solid when it's folded. So this, you could cut that out of paper. I could rip this sheet out of this book. I could cut this out. I could fold along the edges like that, and I could make a solid. That's what a net is. You're going to be asked to draw a few nets today, which should be interesting. If I said, hey, can you draw the net of this triangular prism? Remember a prism has two bases of a certain polygon, and then the faces are rectangles. Draw a net of that. Well, might take you a few tries, but I bet you could figure it out. You could do it like this, or you could do it like this. Either of those would end up like that. Now, the surface area of a polyhedron, which is just a solid that's got polygons for faces, is the sum of the areas of its faces. So if you can break something down into a net like this, you can just find the area of each one of these, and that's what the surface area of that whole solid would be. Okay, so surface area of a prism. A prism has a base, and then another base down on the bottom just like it, and then it's got the rectangular sides. So, you need to find the area of this base, you need to find the area of that base, so 2 bases, 2 times b, and you need to find the area of each of the rectangular sides, which can all be added together as one big length and one width. Now in this case, this is the P stands for perimeter. Why perimeter? Because look up here at this shape. This is green. I don't know if you can see that. Maybe I'll zoom this in a little bit. This is really nifty. I haven't used that word in a while. Nifty. Challenge you. Use the word nifty today. This is the distance around that triangle. It's green. When you unfold this into the net, it would be right here, right? And this one would fold up to be there, and this one would fold up to be there. So that perimeter around the triangle is going to be your big P perimeter length of this big rectangle. Blue is going to be the height of your prism, right there. So P times H is the surface area of all those faces, plus 2B. And that's the surface area of a prism. S stands for surface area, equals 2B plus P times H. Cool. All right, so check this out. See if we can do this example here. Maybe I'll use my mouse for a second. Find the surface area of a triangular prism. So you're going to write the formula out. B stands for the area of the base. The base in this prism is this orange triangle. Triangles we know. Area of a triangle is 1/2 base times height. 10 times 12 is 120. Half of 120 is 60. 10 times 12 times 1/2 gives you 60 for the base of that. Now, 2 times 60, this red, plus, now 13 is the perimeter. What's the perimeter around this guy? Well, 13, 10, and 13, which would be 26, 36, right? 13 plus 13 plus 10, that's the P, times H, which is 15, the height. Okay, because if you stood this triangular prism up on end, 15 would be the height. 15 is the distance from one base, the triangle, to the other base, the other triangle on the back side there. Plug all those numbers in, crunch the numbers, boom, 660 centimeters squared, or square centimeters, because this is surface area, so it's measured in square units. So, formula for the area, surface area of a prism. Kind of a cool formula. You have to know that B stands for the area of the bases, and then P stands for that perimeter around that base. H stands for the height, distance between the bases. You've got to know those things in order to solve this. Now remember, they might give you the surface area and give you the perimeter and the height, and they might ask you to find the area of the base, in which case you would just use your algebra skills, figure that out. Let's do one more here. Surface area of a cylinder. We'll zoom out a little bit. So, the net of a cylinder has 2 circles for the bases, And the curved surface, this blue, can be flattened out to be a rectangle, can't it? So, if you were going to make your own formula for the surface area of a cylinder, what would you do? Well, I would do the area of the top plus the area of the bottom. Those areas are the same. So I would just say 2A, meaning A would be the area of the top. So 2A plus H times, and what is this green distance? It's the actual same distance around this circle, right? Because that's going to get folded around the circle. So this green distance, this length of this rectangle, is the same as the circumference around this circle. What's the formula for circumference? 2 pi r. Man, I think this stuff is cool. So let's see what they do for their formula. Surface area of a cylinder. 2b, b being the area of the base, which would be the circle, right there. 2b plus ch, c times h. C is the circumference, h is the height of the cylinder. This looks pretty similar to the surface area of a prism, doesn't it? 2b plus ph before, well now it's just ch. Instead of perimeter around the triangle, or whatever for the prism, you've got the circumference around the circle. And then this can further divide out to the formula for the area of the base of a cylinder is just the formula for an area of a circle. So that's pi r squared. So now they have 2 pi r squared plus, and then circumference is 2 pi r h. Okay, so that's where they get that. Now, if you just take a moment and look at this whole formula, man, if you would have saw that just a year or two ago in math, you'd have been like, whoa, that's crazy. Look at these weird Greek symbols and these letters and these little numbers up high, you know, but, you know, this is a level you guys are on. So, well done. Find the surface area of the cylinder. Sloppy Joe, find the surface area of this can. Well, let's do this out here. The radius is 1/2 the diameter. So the diameter here is 8, so the radius is 4. We need to find, oh, it looks like they're using this, they're using that second example of the formula for the surface area of a cylinder. So the radius is 4, put a 4 in there, 4 in there, because that's still the radius. The height is the height of the can, 10.7. Stick that in. Multiply all those together after you do the 4 times 4. Okay, 4 times 4, because that's 4 squared. Multiply those together, then add them together. That's what you got for the surface area of the can. Whew, alright. Gonna have to refer back to these blue box formulas here for this section. So, good luck with that. Looks like you got some cool solids you're working with, some interesting looking nets here, and should be a hoot-hollering good time as long as you have budgeted enough time to do this assignment. It should be good.